Hello everyone, my name is Othman and today I'll be explaining three chapters in CSCI 315, which is Design and Analysis Algorithms. And these three chapters are going to be greedy algorithms, minimum spanning tree, and shortest path algorithms. The first section I'm going to explain about is the activity selection. We basically have a table that is filled with activities, and each activity has a start point and a finish point. So as we can see here, we have multiple activities and we have to sort them according to their finish point in increasing order. So we can see here that the finish point is in increasing order. And then we have to choose a start point. We usually start with the first activity. So we have to write that down. I is equal to 1. And then the finish point, F1, is equal to 4. Now, the rule that we're going to follow is that the start point of the second activity or the next activity should be greater than or equal to the finish time of the activity that we earn. So basically here we have to check each and every activity after the first one and see which one is greater than which one has a start point greater than the finish point. The second activity is S of 2, which is equal to 3. Is that greater than or equal to 4? No, it's not. The next one is S of 3, which is equal to 0. Is that greater than or equal to 4? No. S of 4 is equal to 5. Is that greater than or equal to 4? Yes. Oh, I forgot to do the pool jobs, which is equal to... So whatever activities we're gonna choose or select, we have to put them here. So the first one we selected is 1. The second one here, so since the condition works here, so the second activity is 4. And we have to change the I is equal to 4. And the finish point now should be compared with the activity 4, which is equal to 7. Now, S of 5, the start point of activity 5 is 3. Is that greater than or equal to 7? No. S of 6 is equal to 5. That's not greater than or equal to 7. S of 7 is equal to 6. That's not greater than or equal to 7. S of 8 is equal to 8. That's greater than 7. So we have to add it to the list. And we will change the I is equal to 8. And F of 8 is equal to 11. Now we have to compare with 11. So S of 9 is equal to 8. That's not greater than or equal to 11. S of 10 is equal to 2. That's not greater than or equal to 11. And S of 11 is equal to 12. That is greater than or equal to 11. So we have to add it here. And now we have selected 4 activities. This is for the first example. Now let's check the other example. We basically have, we have other types of activities that have different start points and different finish points. And we will, just like the previous example, we will start off by selecting the first one, which is I is equal to 0. And the finish time of this activity is 3. Let's not forget to put the pool jobs, which is equal to, the first thing we put is activity 0. And then we have to check, S of 1 is equal to 3. That is greater than or equal to 3. So we select it and we put here 1. Then we change I is equal to 1. And the finish point for this is 4. Now, we have to compare the next one. S of 2 is equal to 2. That is not greater than or equal to 4. S of 3 is equal to 0. That's not greater than or equal to 4. S of 4 is equal to 5. That is not greater than or equal to... that is greater than or equal to 4. That's greater than 4. So we will select this activity and put it here. Now we change. I is equal to 4. And the F of 4 is equal to 9. Now we'll start with the next activity, which is S of 5. It's equal to 8. That's not greater than or equal to 9. Then S of 6 S of 6 is equal to 11. That is greater than 9. So we do select it, put it here, and then we finish these activities. The next section in the greedy algorithm is the knapsack algorithm, where we have a table filled with objects, and each object has a price and a weight. And also in the question we'll be given the maximum weight. For example, here it's 15 kilograms. We start by looking at the table and dividing the price of each object over its weight. So for example, here it's 5 over 10, which is equal to half. 20 over 2, which is equal to 10. 10 over 5, which is equal to 2. 30 over 10 is equal to 3. And 15 over 7 is equal to 2.14. And then we will have here a vector called vector x. Now, what I like to do is draw a bag, because this knapsack algorithm is, they usually call it like the thief. It's like a thief who's trying to steal all these objects with the maximum price, and he has a certain weight that he can carry, for example. So what we will do first is we choose the maximum price over weight. So like here we will choose this first. Okay, and then we will subtract the maximum weight by the weight of this maximum pi over wi, which is 2. And we will get we get 13. Okay, and then the next object we're gonna choose, and we took the whole thing, right? So we'll put here 1. Okay, let me just give me a second. Okay, so we chose this, and then we'll put here 1. And then the next object we can choose is the next maximum number, which is here it's 3. We'll take the weight of this object, so 13 minus 10, it's equal to 3. Then we took the whole thing, so it's 1. Then now we have 3. So the next maximum price over weight is 2.14. The weight here is 7, and we only have 3 kg left for the thief to carry. So we have to take only 3 over 7. So only 3 from this 7. Okay, so we'll take here, so it will be 3 and it's equal to 0. Now we're done. The thief took the maximum weight, he carried the maximum weight. We're done. Now the last thing to do is the total cost in the bag. Now to calculate that, we have this formula where it's the sum of all the vector x times the price of each object. Here it's 0 because we didn't use these. So what we will do is we multiply 0 by 5, which is the first object. Then the next object, we took the whole thing. The vector is 1 and multiplied by its price, so it's 20 plus 0 times 10 plus 1 times 30. Okay, I don't have enough space. Okay, plus 3 over 7 times 15. Then we can get the total, which is 56.42, if I'm not mistaken. So this is the total cost inside the bag. Now we can see the other example right here. So we have more objects, and then we'll start with the same thing. We have to divide the price of each object over its weight. So let's say 10 over 2, which is equal to 5. 5 over 3, it's equal to 1.66. That's not very... Okay. And then 15 over 5, which is equal to 3. 7 over 7 is equal to 1. 6 over 1 is equal to 6. 18 over 4 is equal to 4.5. And then 3 over 1 is equal to 3. Then again, we draw this box. Okay. And we start with the maximum P over W, which is 6. And the maximum price in here, the maximum weight in this example is also 15. Let's write that down. Okay, so since we chose 6 as the maximum, so we do 15 minus the weight, which is 1, is equal to 14. And vector x, here it's 1. Then the next maximum is 5. Okay, I have to put here 1. And then 14 minus the weight, which is 2, it's 12. The next one is 4.5. And 12 minus 4, which is equal to 8. The next one is 3. We have 2 3s, so choose whatever you want. It's totally fine. Just this one first. So 8 minus 5 is equal to 3. And then we have the next maximum, which is the other 3. The weight here is 1, so we do 3 minus 1 is equal to 2. And then the next one is 1.66. So we have 2 left, and the weight here is 3. So we'll take only 2 over 3. So here it becomes 0, and then here we just put 2 over 3. And here it's 0 because we haven't used it. So now we have to calculate the total cost in the bag, which equals to the sum of the vector x times the price of each object. So 1 times 10 for the first object, 2 over 3 times 5, 1 times 15, 0 times 7, 1 times 6, 1 times 18. Let's move this a bit. Plus 1 times 3. All of this is equal to 55.3. And that's it for the greedy algorithm. Now we're going to talk about the minimum spanning tree, where we have 2 types, or we have 2 sections, the prime and the Kruskal. We'll start with the prime first. We choose the minimum link or edge, the minimum cost of the link or the edge, which is 10 in here. So we need to draw it. And in our new graph that we're gonna draw, we're not supposed to have any cycles, and also we need to get the minimum cost of a tree. So as I said, we need to first select the minimum cost of an edge, which is 10 in here. Please ignore my drawing, it's not the best. Okay, and then since we selected 10, we need to check the other edges that are connected, or we can select from. So we have here 28 and then 23. We will choose the 23. oh my god, no, I mean 5, and here 23. And then the next options we have is 28, 24, and 22. We'll choose the 22. We have 18, 24, and 28. We need to consider the old options that we didn't choose from and the new ones. So 3, 18, and then we have 16, 24, and 28. We'll choose the 16. We have 14, 24, and 28. We'll choose the 24. Sorry, the 14. And now we're done, because if we choose any of these two, we're gonna have a cycle either here or here. And also another way to check if you're done or not, what you do is the number of nodes in the first graph minus 1 is equal to the number of edges in the new graph. So for example here, the number of nodes we have is 1, 2, 3, 4, 5, 7. And then we minus 1, it's equal to 6. Let's check. So we have 1, 2, 3, 4, 5, 6. It's actually 6, so we're done. And now we need to calculate the cost of tree. We add them all up. So 10 plus 23 plus 22 plus 18 plus 16 plus 14, which is equal to 105. The next example is this tree. And so we'll do the same thing. We'll select the one with the minimum edge or link, which is 4 in here. So we're gonna draw 5 connected to 7. Then I'm gonna remove it from here to make it easier. Now we need to check the options that we have to select from. So we have 8, 7, 8, 9, 8, 12. The minimum is, and also 14, 8. The minimum is 7, so we're gonna choose it right here. Draw it right here. Okay, remove this. Okay, now we need to remove this option because if we're gonna choose this, we're gonna get a cycle right here, and we don't want that. So we need to remove it. We're not considering it anymore. Now we have the other options we have is 12, 8, 8, 8, 8, 14, 8, 7, and 6. So the minimum is 6. We're gonna take that to 1, 6. Now we're removing this option as well, because if we put here an edge, and we're gonna get a cycle again. So remove this, and now we have 9, 7, 8, 14, 8, 8, and 8. We're gonna choose the minimum, which is 7. So we'll draw the 7 here. Okay, now since this is done, we need to check the other options. We need to cancel this option because it's gonna create a cycle as well. So we'll cancel this. We're not considering it anymore. Now we have 10, 8, 5, 6, no, sorry, 10, 8, 5, 8, 8, 14, and 8, and 8. We're going to choose the 5. So we draw here a link to 6 and put here 5. Cancel this. So we need to cancel this option and this option because they're gonna create a cycle. Now we have 6. Oops. Now we have 6, 10, 8, 8, 8, 8. We're gonna choose the 6. Oh my god, okay. 6. And we need to cancel this because it's gonna create a cycle. Now we have 13 and 8 and another 8 and another 8 and 10. I'm gonna choose the 8. I'm gonna choose this 8, for example. Take it like that. Okay, now we cancel this option because we're gonna create a cycle, and this one as well, and remove this because we already chose it. I forgot to add, oh my god, I forgot to add the cost of each edge here. Okay, is there anything left? Yeah. So what other options do we have? So we're done with these. Okay, so we have the 8 and the 10. We need to take the 8. So from 5 to 2. 8. Okay, now let's check. So if we take the number of nodes minus 1 is equal to the number of edges in the new graph. So the number of nodes here is 9. Okay, so we do 9 minus 1 is equal to 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so we have 8 edges, so we're done. Now let's calculate the cost of the tree. So we add all the edges up. 6 plus 7 plus 5 plus 6 plus 7 plus 8 plus 4 plus 8, which is equal to 51. Now we will do the other part, which is Kruskal. So here we need to list all of the edges or the links in ascending order according to the weights and the weights of the links, and then we will draw a new graph as well. So let's start. Let's do it step by step. So the first edge we have is 1,6 and its cost is 10. We need to start from the minimum cost of an edge. So here it's 10, the minimum, so it's 10, we put it here. Then the next minimum edge is 14, so we'll choose this. We'll put 2,7 here, 14. And then the next minimum is the 16, so 2,3 is 16. Then we have 3 to 4 is 18, so we'll take that. 3 to 4, 18. And then we have the 22, 4 to 5. And we have the 23. I'm sorry, that's supposed to be 25 actually. Okay, so now we have the 24. So 5, 7 is 24. Now 5 to 6, which is 25. And last but not least, we have the 1 to 2, which is 28. Now we need to build the links from the beginning. So And we ignore the links that create cycles, just like before, but in a different way. So we start with the first one. So we take this, we will draw a link from 1 to 6. Okay, put a 10. Now, we're gonna take the 2 to 7. Yes. So even if they're not connected, it's fine. In the prime, if they weren't connected, we're not supposed to take any link or edge that doesn't connect the nodes together. But in here, it's fine, even if they're not connected. So here, 2 to 7, we can take it even though it's not connected to 1 or 6, but it's fine. 2 to 7. Okay. Now the next one we have is 2 to 3, which is 16. So 2 to 3. I forgot to add this here. Okay. Now 3 to 4. Okay. Now 4 to 5. Which is 22. And then 5 to 7. Now, if we consider 5 to 7, we're going to create a cycle in here. So we need to ignore this and go to the next one. We have 5 to 6. Okay, that'll be good. There'll be no cycles in here. 25, that's correct. And then, what else we have? Yeah, we have 1 to 2, which will create a cycle. So we're going to ignore it. And now we're done. So we need to also calculate the cost of a tree. $10 plus 25 plus 22 plus 18 plus 16 plus 14, which is 105. Let's see the other example in here. So we will start by also checking edge by edge and listing them down in ascending order. I think we need more space in here. Let's see. I think we're gonna write them here. Okay. So 5 to 7 is 4. What other edges? What's the next minimum edge we have here? This one, 3 to 6. So 3, 6, and it's 5. And then we have two options, so we can either select this first or this. It's totally fine. Let's just go 1 to 4 is 6, and then 6 to 8, which is also 6. Is there any other 6? No. Let's go to the 7. So we have 4 to 7 is 7, and 4 to 3 is also 7. Now we're done with the 7s. Now let's go to the 8. We have a lot of 8s. So we have 5 to 2, 5 to 9, 9 to 7, 7 to 8, 7 to 8. So we finished from this, this, and this, and even this. Okay. Now we have 5 to 4. And we have 4 to 6. Okay, now we're done with the 8. Now let's go to the 9, which is 1 to 3. Okay, and then 1 to 2 is 10. we have, so, okay, 12, it's 1 to 5. Okay, let me just take this here. Okay, so what did we say? 12, 1 to 5. We have the 13, which is 8 to 9. And 6 to 7, which is 14. Okay, now to check if you've checked, if you have listed all the edges, just count the number of edges here and the points that you created. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. Okay. So we start the drawing the graph again. We'll start with the first one, 5 to 7. Four, then 3 to 6. Okay, 3 to 6, which is 5. Okay, 1 to 4. Okay, so 1, 2, 4, which is 6, and then 6 to 8. 6 to 8, okay. Six, 4 to 7. It's fine if we select this edge because it doesn't create a cycle. Okay, now 43, which is also 7. 5 to 2. Which is 8. 5 to 9. Which is 8. 9 to 7. We can't select this because it's gonna create a cycle, so we need to ignore it. 7 to 8 is also gonna create a cycle, so we need to ignore it as well. 5 to 4 is gonna create a cycle as well, so we are gonna ignore it. 4 to 6 is gonna be ignored as well. It's gonna create a cycle. 1 to 3 is gonna create a cycle as well right here. 1 to 2 is gonna create a cycle as well. 1 to 5 a cycle. 8 to 9 is going to create a cycle, and 6 to 7 is going to create a cycle. So we can see that we're done. So we need to also check where am I supposed to put this? Okay, the total cost. Let's write it here. The cost of the tree. So we put 6 plus 7 plus 7 plus 5 plus 6 plus 4 plus 8 plus 8. If I'm not mistaken, that's gonna be, okay, let me just recheck. 6 plus 7 plus 7 plus 5 plus 6 plus 4 plus 8 plus 8. That'd be 51. And that's it. The last chapter I'm gonna explain about is the shortest path algorithm. where we have two types of algorithms, Jacquestra and Bellman-Ford. I'm going to start with Jacquestra first. Basically, we have a graph, and this graph is filled with nodes and edges, where each edge has a weight. The first thing to do is to build a table like this, where we have all the nodes at the top, and then we're gonna choose a source or start point. Usually you'll get it in the question, so let's say it's A. So we initialize A with a dash, and then the rest of the nodes should be initiated with infinity. And then in the next row, we're gonna put the source that we chose, or the start point. And let's not forget to put the dash for the whole column A. Okay, and now we have to check the edges that are connected to A. So let's start with B. There is a connection from A to B which has a weight of 2, and 2 is less than infinity. So we put 2, and then we have to put A, because A, it's the point that's connected to B. And then there is no connection to C, from A to C, so we'll put infinity. There is a connection from A to D, which has a weight of 7. 7 is less than infinity, so we'll put 7A. There's no connection to E, so we keep it infinity. No, there is a connection to F, which has a weight of 2. Let's put 2 here. Okay, 2, so we'll put 2A, because 2 is less than infinity. And then there's no connection to G, so we'll keep it infinity. Now we have to choose the smallest number in this row, which is 2. We have the number 2 mentioned twice in column B and F. We can choose either B or F. I'm gonna choose B. And then let's circle it. Okay, and we have to put the rest, the column B, the rest should be dashed. Okay, now let's see the edges that are connected to B. So there is a connection from B to C, which has a weight of 1. So we have to add 2 plus 1, which is equal to 3. Then 2, which is the weight from A to B. And then we have to add the weight that connects B to whatever the node we're checking it with. So 2 plus 1 is 3, and 3 is less than infinity, which is the previous weight that C had. So we'll put 3B. And then there is a connection to D, which is 4. We'll see. 2 plus 4 is equal to 6. 6 is less than 7, yes. So we will choose 6 instead of 7 and put 6B. There is a connection to E, which is 3. So I'll put 2 plus 3. 2 plus 3, which is equal to 5. And it's less than infinity. So I'll put 5B. There is a connection to F. So 2 plus, what's the weight from B to F? It's 5. Okay, so 2 plus 5, it's equal to 7. And then it's less, is it less than 2? No, it's not, so we'll keep it the same. We will not change it to 7, so we'll keep it 2A. There is no connection to G, so we'll keep it infinity. Now we will choose the smallest number in this column, which is 2A, and 2A is for node F, so we'll put F here, and then we will put a dash for the rest of column F. And now let's check the connections that F has. So it has a connection to A, but A is already dashed because it's selected already. We have checked all the nodes connected to A, so we're done with that. There is a connection to C, which has a weight of 4. So we'll put 2, which is the weight of F that we picked the step before, and then 2 plus 4 is equal to 6. It's not less than 3, so we'll keep it 3b. And then there's a connection to B as well, but just like A, we already chose B and we checked all the knots connected to it, so no need for that. There's nothing else, so we'll keep everything else the same. So here's 6b, 5b, and then infinity. Now, the smallest number in this row is 3, which is the node C, so we'll put C here. And let's put a dash for the column C. Okay, now let's see the node C. So C has a connection to F, but we already checked that. We're done with it. It has a connection to B. We're done with that too. It has a connection to E, which is 4. So here 4 plus 3 it's equal to 7. Is it less than 5? No, it's not. So we'll keep it 5b. And then we'll keep everything else the same because C doesn't have a connection to D, so we'll keep it 6b, and it has no connection to G, so we'll keep it infinity. Now the smallest number in this row is 5b, which is the column E, or the node E. And then let's see the connections between E and the other nodes. It has a connection to C, but we already checked C, we're done with it. It has a connection to B, but we're done with that too. It has a connection to D, which is 1, so we have to see 1. So 1 plus 5 is equal to 6. Is 6 less than 6? No, it's not, so we'll keep it 6b. We're not going to change it to 6e. And then it has a connection to G, which is 7. So 5 plus 7 is equal to 12. And it's less than infinity, so I'll put here 12e. We need more rows. Let me just... Okay. Okay, the smallest number in this row is 6b, so we'll choose this, and it's the column D, so I'll put here D. And let's not forget the dashed columns, and D is gonna be dashed as well. Okay, and now let's check D. D has a connection to G, so we'll put 5 plus 6, which is equal to 11. Is it less than 12? Yes, so I'll put here 11D. And this is the last point that we have. So, for example, in the question, we might be asked to see the shortest path from, let's say, A to G. So to do that, we have to check. So G, this is the last number it had, which is 11D. So we will go to D. Let's go to column D. D, the letter it had in its last number is B. So we'll go to column B. And here it's A, so we'll go to A. So the shortest path from A to G is A to B to D to G. And it depends on the question. If you're asked something else, maybe it's from, let's say, B to G or F to A or whatever that is. just go with the question. And also we're going to choose the start point. As I said, the start point usually it's going to be given in the question as well. Let's check the next exercise. So we have this graph, and I've created the table already, but it's not going to be given. You have to create it in the exam or in the quiz or while solving the question. The same thing, we're going to put all the nodes at the top, and we're going to choose a start point. Let's say the start point is S. So we're going to initiate S with a dash, and the rest of the nodes are going to initiate to infinity. And here we're going to put the letter S, which is the start point. And we're going to, let's not forget to put a dash in the whole column S. Okay, and now we have a connection from S to V1, which has a weight 16. And 16 is less than infinity, so I'll put here 16S. There is a connection from S to V2, which is 13. So 13 is less than infinity, so I'll put here 13S. And then there's no other connections, so the rest are gonna stay the same, infinity. Okay, now we're gonna choose the smallest number in this row, and it's gonna be 13S, which is in column V2. So I'll put here in the next row, we'll put V2, and let's put a dash for the rest column V2. Okay, so V2 has a connection to V1, which has a weight of 4. So I'll put here 13 plus 4, it's equal to 17, but 17 is not less than 16. Oh my god, wait. So we will keep it 16S, and then it has no connection to V3, so it will stay infinity. It has a connection to V4, which is 14. So I'll put here 14 plus 13, which is equal to 27. And 27 is less than infinity. So I'll put here 27 V1. Oh, sorry, I mean V2. Because this is the node mentioned here, and this is what we're seeing, the connection it has. And then it has no connection to T, so I'll keep it infinity. Now we're gonna choose the smallest number in the row V2, which is 16S, and it's in column V1, so I'll put here V1, and we're gonna put a dash for the rest of column V1. Now we'll check the connections that V1 has. So V1 has only one connection, which is to V3, and it has a weight of 12. So we'll put here 16 plus 12, which is equal to 28, and it's less than infinity, so I'll put here 28 V1. Yep, and the rest are gonna stay the same, 27 V2, and here infinity. Now we're gonna choose the smallest number in row V1, which is 27, and it's in column V4, so I'll put here V4. And now the rest of the column V4 is going to be dashed. I think I have to put an extra row. Okay. Okay, so as I said, let's check the connections that V4 has. It has a connection to V3 and T. So V3 the connection between V4 and V3 has a weight of 7. So I'll put here 27 plus 7, which is equal to 34. And this is not less than 28. So we'll keep it 28 V1. And then it has a connection to t as well, which has a weight of 4. So I'll put 27 plus 4, which is equal to 31, and it's less than 18. Less than infinity. So we'll put here 31v4. Now we're gonna choose the smallest number in row v4, which is 28, and it's in column v3. So I'll put here v3, and let's put the dashes here, and we'll also put the rest of the column v3 dash as well, v4 as well. And then v3 has a connection to t, which is 20. So 28 plus 20, it's equal to 48, but it's not less than 31. So I'll keep it 31v4. And now we're done. Since all the nodes are checked, that we're good. Now, again, in the question, we might be asked to find the shortest path from, let's say, V2 to S. So we'll check V2. V2 here, the letter it has in its last number is S. So it's directly to S. So I'll put here S to V2. That's it for Jacques-Castro algorithm. Now let's go to Bellman-Ford. Okay, in Bellman-Ford, it's the same thing. We're gonna have a graph, and this graph is gonna have edges and nodes. But the difference here that the weights can be negative. In Jacques-Castro, negative edges don't work. But negative cycles in both of them are not gonna work. Because the shortest path is gonna get decreasing and decreasing, so we want to find the shortest path ever. Okay, let's check Bellman-Ford. So in this example, the first thing to do is create a table, and this table is gonna have all the nodes at the top, just like the Jacques-Castro. However, the difference here is there is a difference actually when applying these steps. We're gonna check it out together. So the first thing to do after doing the table, we're gonna put all the nodes that are connected, or I mean like all the edges that we have here. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges. So we're gonna mention them on this side just to make it easier on us to check them all. So I'll put here, there is a edge from 1 to 2, from 1 to 3, then from 1 to 4. There is a connection from 2 to 5. There is a connection from 3 to 2, and 3 to 5, and then from 4 to 3, and from 4 to 6, and then 5 to 7, and 6 to 7. Now let's make sure that we have 10 points here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. We have 10. We're gonna check them one by one. And also, let's not forget to initiate the nodes. So let's say 1 is the source, so it's going to be initiated 0. We'll put it on top of each node. We'll put the initiated value at the top of each node. So 1 is initiated to 0, and the rest are initiated to infinity. Okay, and now let's check each and every point we have here. So the first point we have is 1 to 2. So 1 to 2 has a weight of 6, and 6 is less than infinity. So the 2 is gonna have the weight 6 instead of infinity. And then the next, so we're done with this now. Okay, and then we have an edge connecting 1 to 3, which has a weight of 5, and 5 is less than infinity. So we will change infinity to 5, and then there's a connection from 1 to 4, which has a weight of 5 as well. So 5 is less than infinity. We'll change this to 5. And then the next point is 2 to 5. 2 to 5 has an edge that has weight of -1. So what we're gonna do is we subtract the values that node 2 has, subtracted by 1. So this means that 6 minus 1 is equal to 5, and 5 is less than infinity. So we'll change this to 5. And we're done with this. Now the next one is 3, 2. Okay, this is 3 to 2. And 3 has, I forgot to put the edge here. Oh, I made a mistake. Okay, basically this is here, and this is 1. Sorry for that. Okay, so as I said, the edge 3 to 2 has a weight -2. So we're gonna subtract 5 by 2. So 5 minus 2 is equal to 3. And now the new weight of 2 is 6. So we're gonna compare it to 6. Is 3 less than 6? Yes, it is. So we will change it to 3. Now 2 has a new weight. Now we're done with this as well. 3 to 5. So 5 plus 1 is equal to 6. But 6 is not less than 5, which is the weight that node 5 has. So we will not change it to 6. We will keep 5 with the same number it has, which is 5. And then next one is 4 to 3. 4 to 3, the edge has -2. So the edge is -2. So we'll subtract 5 by 2, which is equal to 3. And then 3 is less than 5. So we'll change the number that 3 has to 3. We're done with this. Now 5 to 6. We have an edge that has a weight -1. So 5 minus 1 is equal to 4, and it's less than infinity. So we will put here 4. Let's choose this. Okay, so 5 to 7. 5 to 7, the edge has a weight 3. So we'll put here 5 plus 3, it's equal to 8, and 8 is less than infinity. So we'll change this to 8. And then the last point we have is 6 to 7. So 4 plus 3 is equal to 7. And then 7 is less than 8. So we will remove 8 and put 7 instead. Now all the points that each node has, we're gonna mention it in the table. So the node 1 is gonna stay, we're gonna just put here source, because it is the source, so it doesn't have a value. It's 0. It's always 0. 2 is 3, 3 is 3, 4 is 5, 5 is 5, 6 is 4, and 7 is 7. Now this is for the first iteration. Iteration 1. We have to do it multiple times. Now the condition here is when we have 2 rows and these two rows shows that there is no difference between them, then we're gonna stop. We'll see that together. So let's just copy this. We need the graph again because it's gonna be hard to do the second iteration on the same graph, so it's better to just draw it again. Okay, let's just remove these. And let's keep the values that let's keep these values. I'm gonna put them again, it's fine. Okay, let's put them again so we can check it from the table directly. So here it's 0, 3, 3, 5, 5, 4, and 7. Now we're gonna check these points again. I'm gonna use them again here. So let's just put it here, it's fine. Okay, so the point connecting 1 to 2 has a value 6. The edge that's connecting 1 to 2 has the value 6. 6 is not less than 3, so we'll keep it 3. And then the edge connecting 1 to 3 has a weight of 5. 5 is not less than 3, so we'll keep it 3. The edge connecting 1 to 4 has a weight of 5. 5 is not less than 5, so it's just gonna stay the same. I think I'm just gonna change the colors just to make it easier on us to understand where we reached. Okay. Yeah. So the next point is 2 to 5. So 2 to 5 has the edge has a weight of -1. Now the new value of 2 is 3. So 3 minus 1 is equal to 2, and 2 is less than 5. So we're gonna change this to 2. And then 3 to 2, the edge has a weight of -2. So we'll put here 3 minus 2, which is equal to 1, and 1 is less than 3. So we're going to remove this and put 1 right here. And then 3 to 5, the edge has weight 1. 3 plus 1 is equal to 4, and 4 is not less than 2, so we'll keep it 2. 43, we have the edge has a weight of -2. 5 minus 2 is equal to 3. 3 is not less than 3, so it's gonna stay the same. The next point is 4 to 6. So 5 minus 1 is equal to 4, and then 4 is not less than 4, so it's gonna stay the same. 5 to 7, the weight of the edge is 3, and the 0.5 has the value 2, so 2 plus 3 is equal to 5, and 5 is less than 7, so change this to 5. And the last point we have is 6 to 7, which means 4 plus 3 and it's equal to 7, but 7 is not less than 5, so it's gonna stay 5. Now we're gonna update the table and put the values of the second iteration. So here it's gonna stay 0. 2 has value 1, 3 has a value of 3, 4 has a value of 5, 5 has 2, 6 has 4, and 7 has 5. Now we can see there's changes happening. We can see a change in this between in these two rows, and there's a difference here as well and here. So we need to do the third iteration. Okay, let's do the third iteration right here. Okay, let's remove these again. Okay, so let's put the values of the second iteration on the nodes. So here it's 0, 1, 3, 5, then 2, 4, and 5. Okay, so we will use the same points that we did here. We're gonna use them again. So from 1 to 2, the value of the edge is 6. 6 is less than 1. No, it's not, so it's gonna stay 1. Then from 1 to 3, it's 5. 5 is less than 3. No, it's not. It's gonna stay the same. 1 to 4 has the edge has a weight of 5. 5 is less than 5. No, it's not. And then 2 to 5. So 1 minus 1. Since the 2 has the value 1 and the edge is minus 1, so 1 minus 1 is equal to 0. It's less than 2, yes, so we will change this to 0. And then, what else? Oh, yeah. So 3 to 2, 3, sorry. Okay. So 3 to 2, 3 has the value 3. And then minus 2, it's 1. So 3 minus 1 is equal to, 3 minus 2 is equal to 1. 1 is not less than 1, so it's going to stay the same. 3 to 5, so it's 3 plus 1, which is equal to 4. 4 is not less than 0, so we'll not change that. 4 to 3, so 5 minus 2 is equal to 3. It's not less than 3, so we'll keep it the same. Okay, and then 4 to 6, 5 minus 1 is equal to 4, and it's not less than 4, so it's going to stay the same. And then 5 to 7, so the new value of 5 is 0, and then 0 plus 3 is equal to 3, so it's less than 5. We're going to change the value that 7 had, which was 5, to 3. And then the last edge we have is from 6 to 7. So 4 plus 3, which is equal to 7. 7 is not less than 3, so we're not going to change that. Let's update the table for iteration 3. I don't know why okay. So here 0, 1, 3, 5, then 0, 4, and 3. So there is a change in these two rows. So we're going to do iteration 4. Let me just add a page. Okay, let's draw the graph again and remove the old nodes. No, let's keep this. Okay, and let's put the new values of the nodes. So we have 1, 3, 5. Okay, 1, 3, 0, 4, and 3. Okay, and we're gonna use these same points. I'm just gonna drag them down. And let me just put the table under that graph to make it easier. Okay, so the first edge, or the first connection we have, is from 1 to 2. 6 is less than 1. No, it's not, so it's gonna stay 1. 1 to 3, it's 5. It's not less than 3, so we're not gonna change that. Okay, 1 to 4, it's 5. 5 is not less than 5. And then 2 to 5, so it was 1. 1 minus 1 is equal to 0. It's not less than 0. It's gonna stay the same. 3 to 2, so 3 minus 2 is equal to 1. 1 is not less than 1, so it's gonna stay the same. We have 3 to 5, so 3 plus 1 is equal to 4. 4 is not less than 0, so it's gonna stay the same. 4 to 3, so 5 minus 2 is equal to 3. 3 is not less than 3. And then 4 to 6, 5 minus 1 is equal to 4. 4 is not less than 4, so no changes occur here. And then 5 to 7, we have 0 plus 3 is equal to 3. 3 is not less than 3. And then the last edge is between 6 and 7, so 4 plus 3 is equal to 7. 7 is not less than 3, so no changes occur. Now we can see here that there are no changes. Let's just put it on the table. So the value of node 1 is 0, the value of node 2 is 1, 3 is 3, 4 is 5, 5 is 0, 6 is 4, and 7 is 3. So we can tell that in the last two iterations, no changes occurred. So since there is no change, so we're gonna stop here. And we're done with this. Let's check another example for Bellman-Ford. This is the last example we're gonna do. So basically, we're gonna do the same thing. We're gonna create a table with all the nodes at the top, and then we're gonna choose a start point, which most likely is gonna be given in the question. Let's say it's gonna be the node A, so put here it's the source, and put here 0, and the rest are infinity. So here's 0, infinity, 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 infinity. Let me just copy this before we start, so it's gonna be easier for us to use the graph in the other iterations. Okay. And then let's put all the edges that we have on the side. So we have how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 edges. So A to B, A to F, and then B to F, then B to C, then we have F to D, and D to B, D to C, D to H, H to C, and last but not least, H to F. Okay, we have 10 points, so we're good. Now we're gonna start with the first point, which is A to B. A to B has a weight, the edge from A to B has a weight of 7. So 7 is less than infinity, yes, so we're gonna choose infinity to 7. And then, let's remove this, okay. And then the second connection, or the second point we have, is from A to F, which has a weight of 6. 6 is less than infinity, yes. We can change it to 6. And then we have from B to F. B has the value 7, and the edge that connects B to F has a weight of 4. So we're gonna add 7 plus 4, it's equal to 11. But 11 is not less than 6, so we're gonna keep it 6. We're not gonna change that. And then let's remove this. Okay. And then from B to C, so B has the value 7, and the connection from B to C has a weight of 6. So 7 plus 6 is equal to 13, which is less than infinity. So put here 13. And then from F to D, from F to D, where's F to D? Oh yeah, found it. Okay, so F has the value 6, and then 6 plus 2 is equal to 8. Let me just put it here. Okay, 8. And 8 is less than infinity, so we'll change this to 8. And now D to B. So D to B, we have the value of the edge is -5, and the value of D is 8. So 8 minus 5 is equal to 3. And now 3 is less than 7. Yes, so we're going to change the value of B from 7 to 3. And then, let's remove this. Okay. And then from D to C, D has the value 8, and the edge connecting D to C has the weight of -3. So subtract 8 minus 3, which is equal to 5. And 5 is less than 13. So we're going to change this to 5. We have D to H. So 8 plus 2 is equal to 10, and it's less than infinity. So we'll change this to 10. Okay, and then let's remove this. Okay, and then H to C. So the value of H is 10, and 10 plus 1 is equal to 11, but 11 is not less than 5, so we're going to keep it 5. The last point we have is H to F. H has the value 10, and has the value of 10, and 10 plus 5 is equal to 15, but 15 is not less than 6, so we're not going to change that. And now let's put the new values in the iteration 1. Okay, so B has the value 3, C has the value 5, D has the value 8, and F has the value 6, then H has the value 10. Now let's do the second iteration to see if no changes occur or changes happen or not. So we'll put this here. Okay, so we'll change the values that each node had. So here 3, 5, 8, 6, and 10. Okay, now A to B, the weight of the edge connecting A to B is 7, but 7 is not less than 3, so no changes occur here. A to F, it's 6. 6 is not less than 6. B to F, so the node B has the value 3, and the edge connecting B to F has a weight of 4, so 4 plus 3 is 7, but 7 is not less than 6, so no changes happen here. B to C, the node B has the value 3, and the edge connecting B to C has the weight of 6. 6 plus 3 is equal to 9, but 9 is not less than 5, so no changes occur as well. Then F to D, so F has the value 6, and the edge has a weight of 2, which is 8. 8 is not less than 8, so no changes occur as well. D to B, so 8 minus 5 is equal to 3, but 3 is not less than 3, so no changes happen. D to C, 8 minus 3 is equal to 5. 5 is not less than 5, no changes happen. D to H, 8 plus 2 is equal to 10, but 10 is not less than 10, so no changes happen. H to C, so it's 10 plus 1, which is equal to 11, but 11 is not less than 5. And then the last edge is, or the last connection is from H to F, where H has the value 10 and the edge has a weight of 5, which equals to 15, but 15 is not less than 6, so no changes happen. So we can tell that in the second iteration, no changes occurred. 8, 6, and 10. So we can tell that no changes happened here. So we stop. And we're done. Thank you so much for watching. I hope this video was helpful, and good luck.